Hello viewers, welcome to another episode of knowledge sharing. For today, we are going to look at this question and it says evaluate k times k minus k times k equals to 100. So we are going to evaluate this for us to find the value of k from the given equation. So we are given k times k times k minus k times k equals to 100. So this is the same thing as k to the power of 3 minus k to the power of 2 equals to 100. So when we have this, what we need to do is for us to transpose the constant to the left-hand side. So this is a constant. So this will become k to the power of 3 minus k to the power of 2. When this transposed into this other side, it becomes minus 100 equals to 0. So in this case, we have to the power of 3 here, and we have also to the power of 2. What we are going to do is for us to find the factors of 100 that will give power of 3 and also power of 2. So 100 can be written as 125 minus 25. So in this case, we will place this in the place of 100. So this will become k to the power of 3 minus k to the power of 2 minus into 125 minus 25 all equals to 0. So we have to open this parenthesis. So this will become k to the power of 3 minus k to the power of 2. Minus goes in here, we have minus 125. Minus goes into here, we have plus 25 equals to 0. So here, this will become k to the power of 3 minus k to the power of 2 minus 125, the same thing as 5 to the power of 3 plus 5 to the power of 2 equals to 0. So this is the same thing as here we need to collect like terms, all to the power of 3 one side and all to the power of 2 one side. So this will become k to the power of 3. When this goes here, it will become minus 5 to the power of 3. Then you have minus k to the power of 2. Then this become plus 5 to the power of 2 equals to 0. We can separate this. So this can be written as k to the power of 3 minus 5 to the power of 3 minus, then this is first parenthesis, minus into, when this goes here, it become minus k to the power of 2. Then this goes here, it become minus 5 to the power of 2, all equals to 0. So in this case, we can see that we have different of 2 cube here and different of 2 square here. We recall, we said note, when we have a to the power of 3 minus b to the power of 3 is the same thing as a minus b all into a to the power of 2 plus ab plus b to the power of 2. And also we have, when we have a to the power of 2 minus b to the power of 2 is the same thing as a plus b all into a minus b. So this is a solution of different of 2 cube and also different solution of different of 2 square. So we are going to express each of these parentheses in this solution of different of 2 numbers in these 2 parentheses. Before we do that, we need to go over to this other side. We are going to express this in this format and this. That is this one in this format and this one in this format. So that will give us here, it's going to give us, for this place, our a is k to the power of 3. So this first one will be k minus 5 all into, so we have here k to the power of 2 plus k times 5 plus 5 to the power of 2. So this is what we have for the first parenthesis, which is for this one. Then this other one will still remain. Let's keep minus k to the power of 2 minus 5 to the power of 2 all equals to 0. That is for this one. So we have this. So this can be written as k minus 5 all into k to the power of 2 plus 5k plus 25 minus k to the power of 2 minus 5 to the power of 2 all equals to 0. So we have gotten this. Then we are going to express this in this format. So that will become, this is the same thing as having k minus 5 all into k to the power of 2 plus 5k plus 25 all into, so here we have that as a plus b into a minus b. So this will become minus k plus 5 into k minus 5 all equals to 0. So this is what we have. We can look at it. We have k minus 5 here and k minus 5 here. So if they are common, we can factor it out. So this will become k minus 5 into, when we divide the whole of here by k minus 5, it will give us k to the power of 2 plus 5k plus 25. Then when we divide the whole of here by k minus 5, it will give us minus into k plus 5, all equals to 0. So we are going to open this parenthesis. So this will become k minus 5 all into k to the power of 2 plus 5k plus 25. Then this goes here will become minus k. Then minus times 5 will give us minus 5, all equals to 0. So this is what we have now. So in this situation, we can rewrite this as k minus 5 into k to the power of 2. This is 5k minus k will give us plus 4k. Then we have 25 minus 5 will give us plus 20, all equals to 0. You can see that we have two parentheses here. It is either the first one equals to 0 or the second one equals to 0. So in this case, we are going to look at it one after the other. So the first one, which is k minus 5 equals to 0, or we have k to the power of 2 plus 4k plus 20 equals to 0. So for the first one, which is k equals to, when minus 5 transfers into this other side, it becomes 5. So this is the first value of k that we have. So this second value of k, which is this one, is a quadratic equation. And we are going to use a quadratic formula for us to find the value of k. So in this situation, quadratic formula is in the form k equals to minus b plus or minus square root of b to the power of 2 minus 4ac all over 2a. From this situation, we have our value of a equals to 1, and our value of b equals to 4, and our value of c equals to 20. We are going to substitute the parameters into the quadratic formula, which is going to give us k equals to minus b, which is minus 4, plus or minus square root of b to the power of 2, which is 4 to the power of 2, minus 4 times a. Our a is 1, times c, which is 20, all over 2 times 1. So here, this will become k equals to minus 4 plus or minus square root of 4 to the power of 2 is 16. Then we have minus 4 times 20 is 80, all over 2. So from here, we have that our k equals to minus 4 plus or minus square root of 16 minus 80 is going to give us minus 64, all over 2. So this is the same thing as minus 4 plus or minus root 64 times root minus 1, all over 2. So here k is the same thing as minus 4 plus or minus root 64 is the same thing as 8. Then we have root minus 1 is I. So this is all over 2. We can rewrite this as minus 4 all over 2 plus or minus 8i all over 2. 2 cancel here 1 and 2 cancel here 2. 2 cancel here 1 and 2 cancel here 4. Therefore, the value of k equals to minus 2 plus or minus 4i. So this is the second value of k that we have, which it has two solutions because it has plus or minus. So we are going to separate it. So this was the first value of k, and k1 equals to 5. And also k2 equals to, from here we have minus 2 plus 4i. And also k3 equals to minus 2 minus 4i. So these are the value of k that we have, and it satisfies this equation. We can do a little check for us to see whether our value of k as 5 will give us the solution of the given equation. So from here, we say that check from the question given, let's say k to the power of 3 minus k to the power of 2 equals to 100 at k equals to 5. Let's take the first one, which is k equals to 5. So our k was equals to 5. So substituting the value of k into here, so we have 5 to the power of 3 minus 5 to the power of 2 equals to what? Which is 100. 5 to the power of 3, we all know that is 125 minus 5 to the power of 2, which is 25, equals to what? Which is 100. So here, 125 minus 25 equals to 100, equals to 100. So what we have on the left hand side is what we have on the right hand side. Therefore, k1 equals to 5 satisfy this expression. We can do other ones and see that our k, the solution of k from here will give us value of 100 when we substitute into the left hand side. If you like what we're doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.